Hello everyone, welcome to Study ETech. This is part 3 solution of transformer MCQ questions. Okay, if you haven't watched the previous videos part 1 and part 2, you can watch those because many questions have been repeated from the previous years. Okay, so let's start. First question, the transformer core is laminated to reduce the hysteresis eddy current loss. We have discussed this question previously. If you are watching this video first time, you can watch the part 1 and part 2. Somewhere there this questions has been discussed. Okay, to reduce the eddy current loss, we laminate the transformer core. Okay, so this will be the answer. What is next question? In a transformer, the flux phasor, this question also we have discussed. If we look the transformer phasor diagram, we will see this is the mutual flux phi m, and here there is E1 and E2. So the 90 degree. So we can say flux phasor leads the voltage by 90 degree induced voltage. We can explain this concept in the another way. Let us assume phi m equal to phi max sine omega t. Okay, in a transformer we know that is this is the transformer, assuming this is the core. Okay, and here the n1 number of turns, n2 number of turns, and these are the turns. So the induced voltage here, it will be E1 will be what? Minus n1 d phi m dt. Okay, so by taking the derivative of it, what will it be? Minus n1 phi max cos omega t. Okay, so what will it be? We can write cos omega t as minus n1 phi m sine 90 minus omega t. Okay, so what will I get from here? If I take the minus from here, what will it be? n1 phi m sine omega t minus pi by 2. So what I see, this is a maximum value, let's say sine omega t minus pi by 2. So E1 is phi is sine omega t and E1 is omega t minus pi by t, so 90 degree lagging. Okay, so we can explain it in this way also. What is the next question? In a transformer, the flux phasor. Look, the same question have been repeated. The same question have not have not been copied simultaneously. Look, this is answer 3 and this is 4. So I have scanned from the question papers, so they came, the same questions came. Okay, so let me take it. Will be answer will be the what will be the flux phasor leads the induced EMF by 90 degree, and previous it will also be same. Okay, so the next question, when a transformer is operated at 400 Hz its kVA rating. Look, here the thing is transformers kVA rating is inversely proportional to F, meaning the kVA rating is actually the size of the transformer. Okay, the size of the transformer, right? So the size of the transformer, as we increase the F, we increase the frequency, size will decrease. Okay, so that's why in aircraft we use high frequency. Okay, so that's why the size will be lesser. In the communication people, they also use the frequency to be higher. Okay, so the size will be lesser. Okay, so in that case, what we can say, if it is frequency is 400 Hz, so this is 8 times, so the kVA rating will be 1/8. Okay, so it will be reduced by 8 times, meaning 1/8. Okay, next question. To draw the phasor diagram of a reactive circuit having a number of branches connected in parallel across a common voltage, which of the following is more convenient to use as a reference phasor? Look, when we draw the phasor diagram, let's take a series circuit R, L, C. What you did? AC voltage source. Okay, so what you did, you see the current is common to all, so we take the current as a reference phasor, right? So in a parallel circuit, what is common to them? V is common, so we should take V as a reference phasor. In transformer we also did the same. In a primary and in the secondary, phi m is common, so we took phi m as a reference phasor. So here when they are connected in parallel, so voltage will be the appropriate answer, right? so source voltage. Next question, which of the following is not true for the leakage flux? We have also discussed the same questions. It links both the winding through here. This is wrong, right? So this will be the answer. This is wrong and this is the answer. Next question, what is done to balance the MMF setup due to the secondary current? We have also discussed this question previously. Transformer is a mutually coupled device. Okay, so primary and secondary, they are coupled via magnetic flux, and magnetic flux is in this core. So this is the primary and this is the secondary, right? So if the some load is connected here, what will happen? It will draw extra current from here. What, from where this extra current will come? From this source, because this is primary means source is connected, secondary means load is connected. So it depends on the source in which side, left side or right side is the wrong concept. If you know in this way, left side, right side, primary, secondary, this is wrong. The source side and the load side. Source side is called the primary and the load side is called the secondary. Okay, so what they are asking, what is to balance the secondary MMF? Look, whenever the current is flowing, the flux is set up phi m, right? So phi m will flow. If you connect some load, what will happen? It will oppose the main flux because the induced EMF, Lentz's law will be satisfied here, right? So whenever the current is flowing, it will oppose this flux. It will generate another flux, secondary MMF, right? So it's like this. It will generate its secondary flux. So I think it will be in this direction. Okay. So main flux is in this direction, it will be in this direction. It will oppose it. Once it is opposing it, phi m will decrease. Once the phi m is decreasing, you can say that is a induced voltage E. E depends on the phi, so phi will decrease, right? So once the phi, E is decreased, the current is nothing but the supply voltage minus induced EMF by this impedance. So the current will increase. Basically, this current will increase. Primary current, and this current will increase the phi. So you can say in this way, this is coupled circuit. This circuit and this circuit, primary and the secondary, they are coupled via this magnetic flux, which is constant. So what will happen if it draws extra current from here? To keep the flux constant, it will draw more current from the supply. Okay, so that is evident that the transformer transfers the power through its magnetic circuit, okay, to the secondary side. So that's why you can say secondary, it will draw extra current from the supply. So current in the primary will increase. That will be the answer. That is the end of this part 3 lecture on the transformer. We have discussed all the questions from 2008 to 2017. Okay, that they appeared in 2008 to 2017 WBUT semester papers. Okay, so if you have any questions, you can put in the comment box. If you have any other questions, you can also put it in the comment box. I will make another videos on that. Your feedback is very important. Okay, so if you have liked the video, please share among your friends and subscribe the channel and press the bell icon to get the further notification for the next video upload. Okay, thank you.